Hi students, welcome back. Today we're going to start with chapter 17. The topics of chapter 17: reaction rates in equilibrium, characteristics of equilibrium, application of equilibria, how can we influence an equilibria, and if we have time we're going to look at reaction rates and kinetics. First, reaction rates. There are 5 factors that influence the rate of reaction. I come back on these 5 factors later on. But first of all, we have the type of reactant. Some compounds react, others not, just the characteristic of a compound. Second, surface area of the reactants, concentration of the reactants. Number 4, temperature of my reactants. And number 5, the presence of a catalyst. So remember, a couple chapters ago we looked at the collision model, that reactions can be explained with collision model. For an effective collision, or that's a chemical reaction, my particles, my reactants need to have the right direction and speed. If they have a collision, then we have a reaction. When you finish this movie with the explanation, go to this presentation on Schoology and watch this movie. It explains as a cartoon style the collision model with the reaction rate, the different factors. Okay, just look at this movie. It's fun. So reaction rate, come back at the 5 factors. So the first one, type of reactant, some will react, some will not. If we have wood, we can burn wood. But if we have stone or concrete, it burns a little bit less. It's much more difficult. So it's the characteristic of a compound. Surface area. Higher surface area, increase of my reaction rate. If I have one piece of wood or wood chips react much faster, easier to burn. So the surface area is important. The concentration of my reactants. If I increase my concentration, I have an increase of my reaction rate. If I have more particles, there are more chances that they will collide with each other, and then we have a reaction. Temperature, increase my reaction rate. Remember, high temperature, particles have more speed, so I have more chance for collision. So increase temperature, increase reaction rate. And then a catalyst. You saw it in the movie, or you can see it in the movie, as the matchmaker. The catalyst itself is not part of the reaction, but it makes the reaction possible. Would increase the rate of the reaction. Equilibrium. Equilibrium with reaction both ways, forward and reverse. First, when you finish this presentation, watch the presentation again on Schoology and look for this YouTube movie. So equilibrium. So far we looked at reactions, reactants, results in products, and we have the reaction arrow. But there are many reactions that have both a forward reaction as a reversed reaction. So we have N2 plus H2 becoming ammonia, Na3. But at the same time, ammonia is decomposing back to N2 and H2. So we have a forward reaction, that's a reaction to the right, so to products, and a reverse reaction to the left, so to the reactants. And these reactions continue all the time, they don't stop. So Na3 is formed, but is also reacting again back to N2 and H2. So all the time the reaction doesn't stop, all the time we have a forward reaction and a reverse reaction. But at some point, the reactions are in equilibrium, and that means the concentration of Na3 in moles per liter and the concentration of N2 and H2 in moles per liter are not changing anymore. So we still have a reaction, forward and reverse, but the concentration are not changing anymore. And that's what we call an equilibrium. And that's a dynamic state where the concentrations of all reactants and products remain constant. So we still have the reactions, but the concentrations are not changing anymore. So let's have a look at the following reaction. N2 plus another N2 gives me N2O4. NO2 is a little bit brown reddish gas, and N2O4 is colorless gas. In an equilibrium, we have 2 NO2 in an equilibrium with N2O4. And the equilibrium depends on the temperature. NO2 is brown reddish gas, and N2O4 is a colorless gas. So again, after this presentation, look at Schoology for the PowerPoint of this. Watch this movie and you see what's going to happen when I place NO2 or N2O4 in ice or in temperature of water with a higher temperature. And you see equilibrium is changing. You can see it on the color of the gas. So, what we said, an equilibrium is a dynamic state where the concentration of my reactants and products are the same, are not changing anymore. So for this reaction, for N2NO2, 2NO2 becomes N2O4. When we start this NO2, it reacts to N2O4, but the reaction also goes back. So in the beginning we see an increase of NO2 and a decrease of N2O4 because the reverse reaction and the forward reaction, they still are happening. But at some point you can see along the y-axis of concentration, the concentration are not changing anymore. So I still have my reaction, but the concentrations are not changing anymore. And from here on, from this moment, where's my, yes, here it is. From this moment, I have an equilibrium. The concentrations are not changing anymore. So, about reaction, we can talk about two types of reaction, a homogeneous and a heterogeneous reaction. What are the differences? Well, it's quite easy. If I have the reaction in only one phase, we call it homogeneous. If I have more than two phases, heterogeneous. Examples, H2 plus O2 become H2O. You see there's a gas, and the gas only one phase, homogeneous, while we have here a solid with a solution becoming a gas and a solution, more than two phases, solid, solution, and gas, we call it heterogeneous. Okay guys, that's it for today. I want you to study chapter 1 from our textbook and look again at this presentation and watch the movies in this presentation. Okay, that's it for today. Bye-bye. Good luck.